In this video, I'm going to show you how to complete Chapter 6, Exercise 1. So this is a textbook assignment that we will be drawing up in Inventor. So we are given the orthographic views of this, meaning we are given the front, the top, and the side view. And now your direction is to create the 3D part in Inventor and then create the drawing file to properly dimension it. As a side note, the grid spacing on the bottom is 0.2 inches, meaning that each one of these is 0.2 inches. For simplicity's sake, let's just say that each grid is 1 inch. So this is the front view right here, which is going to be a good place to start by drawing it. So I'm going to draw as my sketch 1 this shape right here, and then I'm going to extrude it the depth involved, which is going to be shown from either the top view right here or the side view right here. Either way, the depth extrusion is going to be 6 units. So we can kind of do a little bit of counting beforehand. We go up 1, 2, 3, 4, 5, 6, up 8, over 3, over 9, up 2, and 3, up 2. All right, we'll see if we can remember that as we draw it. So we're going to come over here, do a new English part, start a sketch. Sure. I'm also using Inventor 2018. It's 99.9% the same as 2020. If for some reason you have an issue finding the button that I use on your version, let me know and I can let you know where you can find it. So we're going to start 2D sketch. I like to do the XY plane. And I'm going to start at the origin, make sure that the green dot is there. You can zoom out a bit and then hit the middle scroll wheel to pan. And it's good to kind of be able to see the line in its entirety. Now it's a little bit too far out. And you're going to have your first one be 8 going up. And then you're going to move over 3. And you're going down kind of an unknown amount, right? So you can either just draw it somewhat in and then add dimensions later, or you can hit escape, go back into the line command, and then start going in the other direction. So that's 9 in this direction, always making sure that you are perfectly vertical and perfectly horizontal. The way you can check is by as I get close to the line, you'll see me click on it, and then you'll have that little constraint bar show up, showing you that perfectly 0 degrees, perfectly on the x-axis, perfectly horizontal. And I'm going to say 9, enter, up 2, over 3, up 2, and then I could connect the dots. I can hit escape now, and notice how when you hit escape, you'll get out of the line command. Okay, so we are fully constrained. That is a good way to kind of spot check yourself. And now I'm going to add a circle. Now, circles require 3 dimensions in order to be able to locate and describe the circle. You need 3 dimensions for each circle. The first dimension would be to tell you the diameter, and the next 2 dimensions would be to locate it both horizontally and vertically. So I'm going to just put a circle, and I'm not going to specify the dimension yet to prove a point. I'm going to put it out here and hit escape, and look, 3 dimensions needed. So we went from fully constrained to needing 3 dimensions because each circle requires 3 dimensions to properly describe it. I'm going to hit dimension, and I'm going to click on the circumference of it, pull it out, and tell you I want this to be a diameter of 2. Boom. Now we have 2 dimensions needed. And now I'm going to click on it, and I'm going to locate this circle via the center point. So I'm going to say center to the origin, and then you can either do a vertical or a horizontal dimension. You're going to have to do both, so it does not matter the order. We'll do a vertical first. I want the vertical dimension between the origin and the center of this circle to be, what is that? 1, 2, 3, 4. To be 4 units. And now it's on the right vertical plane, but not the right horizontal. So you're going to have to do the same thing again, dimension, click the origin. Make sure you're getting the origin, right? I guess sometimes these lines will work, but I think it's good practice to use the origin. And now the horizontal distance is going to be 3. And now we can see we are fully constrained. You can finish the sketch, extrude it. It might not give you a preview because it doesn't know which closed geometric shape it wants to extrude. So just click right here and specify you want to extrude it 6 units. And that's it for this drawing. Well, this part drawing, I should say. This is one way of drawing this part. There are easily a dozen ways you could have approached it using different sketches, different orientations. As long as it's a somewhat efficient drawing and you get the same finished product in the end, then you meet the requirements. You don't necessarily have to do it the way I did. You don't necessarily have to do it in the most efficient way, as long as you have a finished product that is good. So now we're going to have to save it, because in order to do a drawing file, we need to have a part file that we can reference into it. So I'm just going to save this on my desktop. Or actually, I have a folder for Brookdale Community College, and we'll call this week, which week are we in? I forget. 3, or maybe it was 2. No, I think it's 3. And this is chapter 6, exercise 1. And it's gonna really help to have it be organized, or else you could save it in the wrong spot, and then you have like what they call unresolved links, where it's trying to pull a file that's not saved in where it was previously, and then you might lose some work. So now that we have the part file saved, we are ready to create a drawing file. So we're going to go back to New, Drawing, ANSI, which is American National Standards Institute, something like that. IDW, Inventor Drawing. We need to then, for every one of these, adjust the sheet specifications. So the default is a 22 by 34 inch sheet, which is very large. For this class, we want it to be an 8.5 by 11. So you're going to right-click Sheet 1, edit the sheet, and make it a size A, not a size D. 8.5 by 11, okay. It makes the title block huge. Let's delete the title block. And then we're going to go to Drawing Resources, Title Blocks, and ANSI A is a smaller one. Let's insert that. Right-click it, and then hit Insert. Now we are ready to import our part file. So under Place Views, you're going to hit Base. Inventor says, okay, he probably wants this part because that was the other drawing I have, or the other part I have open, and it's the one I saved most recently. If for whatever reason it did not give you that one, you can just as easily go to Open an Existing File and find wherever you saved it. So let's go from the top. Base, I'm going to move this over by clicking in the green area, and then before I click anything else, I'm going to move my mouse up. And look, I could just as easily place my top and my right view. You can even, if you wanted, put in isometric as well. And then you can hit OK. Or you can adjust a few settings. Hidden line should be on. Hidden line removed for whatever reason if you wanted that. And then shaded also gives you some color. You can also adjust the scale as well. And you can hit OK. If you wanted to delete this, you can click on it and hit delete. I'll show you something else as well while we're here. Say you only included the base view, and then you want to include the top or side view later, you can go to Projected, and then look in the bottom left. In the bottom left is Inventor telling you what it wants from you. So if I want to do Projected, but I need to kind of learn like the steps in order to do that, you can do, okay, select a view. Well, I want to project this view. Select. Select view location. Okay, I want to locate it right here. Select view location or choose create. Well, I want to do another view location. Now I want to create it. So I have to do the right-click menu, create. And now it's good. Notice how this automatically includes all my object lines and all my hidden lines. Hidden lines, of course, are represented by dashed lines. Next, you are going to want to include center marks and center lines. So you're going to go to Annotate. Center marks are like the little crosshairs. They're a target or a scope. And then you just click that, and then click the circle, and it automatically appears. Center lines, you're going to click, for now, center line bisector. But we're going to notice something. The center line of this hole right here occurs at the same location as an object line, right? The halfway point between these two hidden lines are right here. So, order of operations will state that if I have an object line and a center line at the same instance, I'm going to show the object line. So I'm actually not going to do as a center line for right here, and the same thing for right here. If the circle was moved over, let me just show you. Now this is just an if. Don't get confused, don't change yours. Let's just say that this was moved over, for example. Let me move that a little bit just so it's not directly on the edge. So 1.25. Notice how it changes it automatically over here. And now I would require a center line over here. Since you want to say, this hole right here is actually a circle. So you're going to hit center line bisector. If you don't know how to use it, look on the bottom left. Click on a location. Okay? The center line is going to be between what two lines? Here, click, and here, click. Boom. Automatically populates. Of course, I don't want that, so let's go back and undo some of the changes we made. And we will resume. We have the center mark and no center lines because of the fact that the center line occurs where an object line appears. Okay, now we are ready for some dimensions. So we went over all the rules for dimensioning last class, and there are a bunch of them. So you got to try your best to remember the rules. Sometimes you have to break rules to make the object look better, or to break one rule to not violate another rule. But at the end of the day, you want to have a part that's properly dimensioned and that looks good and neat. So I'm going to do dimension and start dimensioning things. If you go back to your sketch, so let's edit the sketch for a second. You can either edit the sketch by right-clicking here and then going to edit sketch, or you could expand this to find your sketch 1 and do it there. Here are all your dimensions. So I have a 2 right here, I have a 4 right here, I have an 8. Those are all my height dimensions. So we can go ahead. Now to dimension, you can either click on the line and when it's red, or you can click when it's a green dot and that gives you point A to point B. You will most definitely be using both. Let's do this. And then you also want to dimension this line. Now, if I just click on it, that looks pretty good, right? It's actually a mistake right here. Remember, you always want to have a gap between the point that you are dimensioning so it doesn't get confusing with the object line. So I'm going to delete that last one and show you what you should have done. Remember, last time I did this, I clicked on the line, and then that was bad. This time, I'm going to do point A right here, and point B is not going to be here, but rather here. Because that will give me the vertical distance in between, but because I'm choosing right here, the gap will now be visible. Boom. Another thing you could have done, now this is perfectly valid, another thing you could have done was go from here to here. We talked in class about baseline views versus chain views. This would be a baseline view, and that would be the previous one would be a chain view. Both are perfectly valid. For the overall height, you might be tempted to do this, but one of the rules said that you should always keep the dimensions between the views whenever possible. You could do either from here to here, It's also equally valid to go from, notice how you can't even do the line, to go from here to here. Either way, does not matter. Both would be valid. I like to do however many dimensions I possibly can on my front view. Okay, so we will continue. I need to do a few width views. So we did my height views, and I gotta do some width views. The width views tell me that I have 3 and 3 and an overall width of 9. So you could do the width from here to here and then pull it up. I'm going to go on the top. I think it'll make it look a little bit cleaner. And then this one, where should we put this one? You could do it like that. That's valid. You could also go from here to here and pull it out of the way as well. A little congested. I'm okay with either. Even like over here I'd be okay with. I just want it looking good. Little messy, but okay. So there is a mistake in this drawing, and I'm going to leave it until the very end to show you. Okay. It's also good practice to keep dimensions lined up whenever possible. So right here is kind of in line with that. Like, it's better to have that than this be like way out here. You want it to look nice and lined up. Okay. You can almost count out the dimensions, right? We have 1, 2, 3, 4, 5, 6. I need my depth ones. So depth can either be here or here. And then I have to do this. So in order to dimension a circle, all you have to do is just click on the red line and pull it out so that you can see it clearly. You definitely do not want to like do something like that. See how it cuts it off? I don't like that. If by chance you're getting this dialog box every single time you do something, uncheck it right here. It says edit dimension when created. Like if you get this, that's annoying, right? No, I don't want to edit the dimension every time I create one. So uncheck it. Okay, hit escape when in doubt, and let's now re-include that. Find a good space where it's not confusing. Okay. Are we done? A way to ask yourself, are you done, is to kind of reverse engineer it, right? You can say to yourself, if I printed this out and handed it to somebody else, can they draw it? Well, let's try it. I start here, and can I draw this shape? I know I'm going over 9, up 2, over 3, up 2 because 4 minus 2 is 2. Oh, gotta pause right here, so I'm up there. Let's go back to the beginning. Up 8, over 3, connect the dots, boom. Now I have this circle. I know the diameter is 2, but do I know where it's located? You might be able to realize, okay, that looks like it's right there. But in the engineering world, you can't make that assumption. So the reason why this drawing is incomplete is I actually did not locate this circle. Remember, you need 3 dimensions to locate a circle. So I'm actually going to delete these 2 dimensions. And instead, here's what I'm going to do. I'm going to say from here, point A, but not here as point B, but rather right here. And what that does for me is it's actually killing 2 birds at 1 stone. It's telling me the distance from here to here, as well as helping you locate the location of this circle. You might be tempted to say, oh look, there's no gap right here. You said that you can't have that. Well, this is kind of like an exception to that. The gap is really located from this center mark right there. And we'll do the same thing as well. Point A, this baseline, and point B is right here. Sometimes you'll notice that like it'll give you a preview. A lot of times that's a good location for it, but you don't have to use that preview. And hit escape. Okay, we're done. Once you are finished, and again, guys, full transparency, this is your answer key right here. This is how you can see if it's working or not. This is what I'm grading you against. So once you have this done, I would do a Control S to save it. Call it the same thing, Chapter 6, Exercise 1. You can name it the same thing because it's a different extension. And then I want you to create a PDF and upload the PDF. So File, Export, PDF, and name it the same thing. Boom. And that is what you will be turning in. That concludes Chapter 6, Exercise 1.